Hello everyone, my name is Zhihang Zhong, a researcher from Shanghai Artificial Intelligence Laboratory. I am excited to present our oral paper, Clearer Frames, Anytime, Resolving Velocity Ambiguity in Video Frame Interpolation. Here is an outline of my presentation. Video frame interpolation, VFI, has a wide range of applications, including generating slow-motion highlights, synchronizing video to music beats, assisting in video generation, and enhancing video compression, among others. Recent learning-based approaches to VFI include fixed-time and arbitrary-time interpolation. Arbitrary-time interpolation offers advantages such as faster performance for any time-step interpolation and no accumulation errors. However, its visual quality often falls short, tending to produce blurry results. The reason for this is that the current training paradigm relies on time indexing for learning. This approach leaves the velocities of individual objects between the starting and ending frames undefined, introducing velocity ambiguity and a multitude of possible time-to-location mappings during training. This ambiguity is further amplified in arbitrary time interpolation. Consequently, models trained with time indexing often produce blurred and imprecise interpolations, as they tend to average out the possible outcomes. Velocity ambiguity consists of two components, speed ambiguity and directional ambiguity. Using a baseball as an example, imagine that the start and end positions of the baseball are the same. At a given time, such as t equals 0.5, the speed can vary, which is referred to as speed ambiguity. Similarly, the direction of the baseball's movement can also differ, leading to directional ambiguity. Our question is, could an alternative indexing method minimize such conflicts? To address this, we propose a more flexible distance indexing approach, instead of using time indexing, to reduce uncertainty during training. We introduce a distance ratio map, where each pixel represents how far an object has traveled between the start and end frames, normalized within a range from 0 to 1. We guide the network to perform more precise interpolation without relying on the ambiguous time-to-location mapping by using a distance map calculated from optical flows. In practice, we found that providing a uniform map, similar to time indexing, is sufficient to simulate scenarios where each object moves at a constant speed along its trajectory. To address directional ambiguity, we introduce an iterative reference-based estimation strategy. This approach incrementally estimates distances, starting with nearby points and progressively moving to farther ones, to mitigate the remaining uncertainty. Our approach addresses challenges that are not bound to specific network architectures. Indeed, it can be applied as a plug-and-play strategy that requires only modifying the input channels for each model. We trained networks using Vimeo 90K dataset. We applied our strategies to state-of-the-art models. For reference, T denotes time indexing, D represents distance indexing, and R stands for iterative reference-based estimation. Qualitative experiments show that models incorporating both strategies produce the best results, yielding the clearest outputs. Quantitative results, including comparisons and ablation studies, further demonstrate the effectiveness of our strategies. We also conducted a user study with anonymous participants. The results align with our qualitative and quantitative findings. The DR model variant emerged as the top-rated, underscoring the effectiveness of our strategies. Instead of using a uniform map, it is also possible to use a spatially varying 2D map as input to manipulate the motion of objects. Paired with SOTA segmentation models such as SAM, this empowers users to freely control the interpolation of any object, for instance, making certain objects backtrack in time. Finally, we present a web app that allows users to experience our algorithms. In conclusion, we propose distance indexing and iterative reference-based estimation to address the velocity ambiguity, achieving clearer anytime video frame interpolation and manipulated interpolation. Then, using multiple frames to estimate an accurate distance ratio map for a specific object is one of future works.